Hello and welcome to Today in Space, the All Things Space Science podcast. And I'm your host from the East Coast, Alex G. Orfanos. And we're here to talk about two big topics for this week. First, I'm going to share my thoughts on Relativity Space's Terran 1 rocket, a 3D printed rocket, the first of its kind, looking to break boundaries. There were two scrubs. We'll talk about those and why I'm still excited, and I'll share some thoughts about our new telescope, the Vespera from Vaonis, what we love about it, and what we're excited to look at. Thanks for joining us. We are here, episode 301. We have a lot to talk about, so let's get into it. As we said, welcome to the show. This episode has been recorded twice now. Let's hope not anymore, but more problems. This one's on me. This technical issue's on me. I know that my Mac, when it stays on for too long, gets a little buggy with the microphone, and I just cavaliered recording the other day. It was kind of cool. We had the SpaceX CRS-27 launch on in the background while we recorded it. It was a crazy, for me, recording it was a lot of fun. There was a lot of things going on. There were a lot of points that I was trying to make and bring a story together here for the show, and then also trying to line it up with the launch and landing of the first stage. And I did pretty well. I was excited, and then the episode died. So it's not releasable, but we're here, round 2. Let's talk about that mission last night. So CRS-27 is really interesting because the CRS series of missions are the SpaceX Dragon missions, where they've been refueling the International Space Station with supplies for the astronauts that live on board. They're bringing up experiments and a whole bunch of other stuff that you need to keep continued human presence on that space station. It's also a good vehicle to bring trash down because you got to get rid of it. You can't just throw it out the window. And there's also experiments that you want to bring back, right? You want to bring back experiments that you did back down to Earth so that you can do more research on the really unique microgravity experiments that they're doing. And the CRS series, the SpaceX missions, are really important for me because my second NASA social, where I was able to go down to Florida to see my first rocket launch ever, it was a Falcon 9 and it was CRS-19. I met a ton of great people. I mean, the experience was incredible. It was right before the pandemic and just was peak space nerdiness. And the group wasn't just a bunch of space nerds, you know? It was people who all had an interest in space with a lot of different backgrounds. It was beautifully put together. A big kudos to the NASA social team that did that. But CRS-19 was really cool. And to talk about later in this episode about relativity and their multiple scrubs, I've seen enough rocket launches now that I've seen how intense the high risk, high reward is of rocket launches. You know, SpaceX has kind of lowered that risk because they launch every 4 days so far this year. I'm sure there's a more accurate number, but roughly they're launching every 4 days. But, let's say for the NASA social that I went to, CRS-19, there was a scrub and there were people that unfortunately had to leave. They had other stuff. That's the rocket business. It sucks. And so what's been really cool is at my day job, where we work at a 3D printing company, and we've been putting on the launches when they happen. And SpaceX is great. SpaceX is awesome, but more specifically with the Relativity Terran 1 rocket, it was a cool experience to introduce a whole bunch of people to the crossing of the streams, the combined universe of space and 3D printing, and it's just cool to get excited about amazing technology like this, and that kind of brings us to the Relativity Terran 1 launch. So Relativity Space was started by Tim Ellis and Jordan Noon. Jordan Noon we interviewed on the podcast. He is working at Embedded Ventures right now, but he was the CTO at Relativity Space. I've yet to meet Tim, but I would love to, because I love where Relativity is going. And the technology that they built, the Stargate printer for Relativity Space, is really interesting. And if you want to learn more about like some of the minds behind that, and like the rocket, the aerospace like rocket, the rocket scientist rock star Jordan Noon, like he was literally launching things into space so high that the military was like, who is this person? Like, why do you want airspace for this? This is a college kid? What's going on? So, it's really awesome conversation. I love what him and Jen O'Brien are doing over at Embedded Ventures. But that's time for another podcast, and we'll have to reach out and talk to them again. But for Relativity Space, the Stargate printer, to really oversimplify it, but you can go to relativity.space and check this out. I think that's the website. Let me just double check, because if they picked up that .space, that's pretty. It's just relativityspace.com, but if they could get relativity.space, that would be really cool. So if you go to relativityspace.com, you can see everything that they do, but they are a company that is 3D printing rockets with, as they say, the world's largest metal 3D printer. And again, to oversimplify it, they use two technologies. They use laser-based metal sintering 3D printing technologies. One is powder bed fusion, which if you're in the 3D printing space, it's been around for a little while. Again, 3D printing is all very new as a technology. It hasn't even been around for 100 years yet. But when you work on enough 3D printers, you kind of see the different variations and you can kind of break down what it is. But really simple. The powder bed fusion is what you would expect. They are laying powder down and fusing the metal, and then they're doing that in layers up until they go to the full height of whatever part they're trying to build, and then they get rid of the powder, which is a very a high safety, like you're in a bunny suit dealing with that, or the room, there's tons of ventilation, there's a lot of that goes into this, and then you have to machine those parts off of the plate that you fused the first powder to. That's what keeps it together as it builds up. So you can do really amazing stuff, but you have to machine it afterwards. The Stargate printer uses a 5-axis robotic arm, and it's basically doing a welding operation. Again, I'm oversimplifying this, but they are with a laser and a filament of metal, a tube of metal like soldering or welding, and they're going around up in circles. So they're building the fuselage, they're building the engine. The Aeon engines are 3D printed. Aeon R will be reusable. Terran R is going to be reusable. So, SpaceX is kind of the standard for a vertically integrated rocket company that from conception of the rocket to building of the rocket, design, building, manufacturing, testing, and refurbishment, almost all of that is done by SpaceX. And what Relativity, and it's a lot of advantages. You can move fast, you can iterate fast. There's a lot of tribal knowledge at all of the different steps, so that ideally a full understanding of the rocket and the system, and they have crew-rated, human-rated spacecraft that routinely go back and forth from the International Space Station, and they're going to be doing missions like the Polaris Dawn mission, the Inspiration 4 mission, which if you haven't seen that Netflix documentary, go check it out. We followed it as it was happening and watched it live, but the Netflix documentary captures the 4 Inspiration 4 astronauts and their journey from being regular citizens that won this thing with Jared Isaacman to then go to space in a Crew Dragon spacecraft. Like, so SpaceX is doing a ton of stuff. And Relativity R has a very similar Relativity Space has a very similar mission statement as SpaceX, in that they want to help build the humanities multiplanetary, interplanetary journey. And I'm butchering right now what their actual one is, so I apologize, Relativity Space. I am pulling up the internets right now. So Relativity Space is building humanity's multiplanetary future. And so it's very exciting, the potential of what Relativity can do. And so the Terran 1 is the very first 3D printed rocket to go on a test stand. Not only did it have wet dresses, which is, if you're not familiar with it, when you fully load the rocket with all the fuel, you don't do any of the countdown, you don't get anywhere close to, lighting that candle and launching that rocket, but you do everything leading up to that, which is a huge part of stabilizing a rocket, is making sure that you can fuel it and have control over it and it doesn't get out of control. So as far as a 3D printed rocket that is 85% 3D printed, has under 1,000 parts total of the whole system that was on the pad. And the payload, there is only a small 3D printed, it's the first 3D print that Relativity had in metal, and it was a failed print, but that doesn't matter. It's actually more unique that way. This is the first thing that was manipulated out of this amazing Stargate machine. And I mean, how can you not love the sci-fi reference? I mean, and it looks like Stargate. That's the craziest thing, is Relativity Space's Stargate machine is kind of printing something out of another dimension, out of the idea realm into reality. It's a wild technology, especially as someone that does work during the day with metals in additive manufacturing. So now a quick word from our sponsors. We've got Manscaped, where you can use our code SPACE, get 20% off the store for anything in there, and free shipping. We've been using the Beard Pro kit, and it's been great. The Beard Hedger Pro. We've also got, there's so many things like just growing a beard itself. I've started using like the beard oil. Man, that has really changed the beard game. Just that thick Greek hair, especially in the winter. It was just getting dry, and the oil has been great. So there's a lot of things like that I got to pick up some more of. But if you're looking for something, if you're a guy, or you're looking for to buy for someone who's got lots of hair and you want the right tools for the job, Manscaped is there with all the stuff that you need, all the tools that you need. And if you're not a beard person, look, there's the Lawnmower 4.0 for hair in other places where you might need to groom. So check it out, manscaped.com, code word SPACE, 20% off, and free shipping. And now, back to the show and talking about 3D printed rockets. I started working in the 3D printing industry because I wanted to see the fusion of manufacturing and space. In my mind, it's a lot of the stuff that I would like to do is off Earth, is in orbit manufacturing, so that you can build large things like the Enterprise from Star Trek. You wouldn't be able to launch that with a rocket off of Earth. It would never get out of the gravitational well of Earth. So you would need to ship it up in pieces. And the only organization that of human beings that would be able to actually accomplish that with enough rockets to do that would be SpaceX right now. And they're not going to do that. They're making Starship. Yes, it has a few tankers that it has to fill it up after it gets to orbit, but that's not, it's not in the same league. So in-orbit manufacturing would allow you to build very massive structures, and that would allow you to completely change the vehicle that you would travel in space in. You could have many redundancies that you couldn't have before, and design things in ways that you couldn't design ever. So, and then there's also, one of the easiest things that we can use as a resource for buildings and prepping our time as we decide to send humans to the moon and to Mars eventually, sending rovers and machinery that can use the soil, the regolith, in situ on the planet to build structures before, and then you can start sending the bits and pieces. And once you have humans there, they really just have to put everything together. So those are the areas of additive manufacturing that I'm ultimately working towards. And working in the 3D printing industry was such a great sidestep into combining the things I was passionate about and working in engineering. So that's why I love it, and that's why this kind of an event with Relativity in Terran 1 is so important. I mean, under 1,000 parts, part consolidation, another huge thing for 3D printing that they're able to use here with their rockets at Relativity Space. So, when you start talking about different advantages for 3D printing, consolidation is used. What things can you think of that are under 1,000 parts total? That is like a piece of technology. Like the complexity for the amount of parts is wild. There's also iteration, right? This is not the very first rocket that they built. And one of the cool things about their manufacturing process is they actually X-ray the microstructure as they're printing it. So they get to detect voids and adjust the process and use software to drive their manufacturing process so that they're able to create something that can match the extremely high material science needs and manufacturing needs, microstructure needs of the aerospace industry. Think about the airliners that we fly every day. Those are engineered to the point where the material science is driving the safety. Like it's the physics of materials and structures, and which is a brutal class. Aerospace structures, man, if you like pain and you like learning things that are really fascinating, aerostructures, check it out. But 3D printed parts are a brand new way of using materials, especially metals. And the amount of money and time and research that has gone into metals that are forged or that are casted so that the microstructure of the metal is as reliable as they can get it. That's how they can reduce the weight of things and get things light enough to fly so that they're fuel efficient enough that you can just basically fly them across the country, stop to stop, refuel, check a few things, and go. Now, that's oversimplification of it, but that's why so many planes are able to do that. And we've seen that there were a lot of years where in many different types of planes that had that kind of reliability. So the aerospace industry, especially the space industry, is very slow to try new things for that kind of reason. There's so much risk, there's so much safety involved that, and I experienced this as an angsty aerospace engineer trying to get my degree. And there were some things at that time that were the go-to thing. Flight heritage, which is not a bad thing, but is something that can be overused to the point of preventing innovation. So, flight heritage is a way of tracking how many times has that thing I'm trying to put on my rocket gone to space, and how reliable was it in space? Because it's an unknown variable. Have you ever launched something into space? Is the vacuum of space going to change it? Are the extreme temperatures of the cold side and the side, or the dark side and the side facing the sun, the extreme temperatures on either end of that thing, and at the center where the greatest change in temperature is happening? Like, things rip apart, and there's the environment of space that you need to be able to test. But if you're so stringent and so stuck in using the same things over and over again because they have flight heritage, and there's not enough money to say, hey, yeah, go ahead, test that thing that you were thinking of, Like, it had to be companies like SpaceX and Relativity Space to put the risk on their back to reap the great rewards if they're successful. So with with Relativity Space, I've done that a few times today. Relativity Space is showing us what a 3D printed metal system rocket can do. One that's 85% 3D printed. NASA would never put on the first time a full rocket like this on the launch pad that was 85% 3D printed. They would have done one that was 30% before that, and maybe 10% before that. It would have been much more progressive. Not very conservative, not as progressive as this, which is their first launch attempt and fueling of a rocket and launching of a rocket is 85%. And I'm sure they're going to want to push that as far as possible. So we were very excited to see that. I'm very impressed with the team that's involved, with the operations of the rocket. Like, they were able to go, they had 2 3-hour windows that they could work in which they were able to launch the rocket in their designated time on the range. So the first time they went through the 3 hours of the window, and basically they ran out of time addressing the issues with the rocket. There were a few things. I'll add some more info in the episode notes if you want to learn more about it. But briefly, a lot of the issues seem to be that when they ran into something that didn't look quite right, they had an abort at like 1 minute and 10 seconds where they didn't see something they liked, which paused long enough while they were figuring it out, where they had to recycle the fuel to keep the cryogenic temperatures and to kind of remix that methane, because that methane oxygen mixture they use for the fuel, the methane loses its potency, so they have to refresh it so that there's enough of it. So it's the right mixture for performance. So that basically was that first day. It was very exciting, but it was also brutal to have like 3 hours, and every time it reset, it was like 45 minutes or almost an hour before the next thing. So for me, I was loving the ride, because to see them save the rocket, which is to go to the point of almost lighting the engines and then taking all the fuel out and making it safe for people to go to the pad again, making the rocket safe so it doesn't blow up. Like, they did that on that first run and didn't have any issues there. Their second attempt was there was also some other issues with fuel where they had to recycle, but the big drama was that when things were looking really good, they had just recovered from a previous hold. And that one was for upper wind shear. So the wind was so bad that it could have ripped the rocket apart. So they were setting up some balloons to check how things were going there. That didn't. That ended up clearing, and then someone in a boat got in the range of the rocket, and it made them have to hold. Like, the Navy must have just took their stuff over there and just ripped them a new one. I would have, but I was pissed. But but it's not the first time that a boat has held up a rocket launch. I remember a few years ago. This has happened before. It's Florida. It's not that surprising, but so the boat happened, and then they ended up getting very close to launching. The engines fired at T-0, and then they were able to take the rocket and safe it, and they tried again to fill that full 3-hour window. They got to the point where they were so close after they had already lit the engine, and then they had to call it a day. So for a scrub, this was definitely a brutal saga of 2 days where there were scrubs, full 3-hour windows, but it was very clear it was a test. They were going to go as far as they could, gather as much data as they could. That's what we love about SpaceX. They get many at bats to try and get more data, to learn more, so they're more successful later. And they learn about the end goal as they're getting to it. So, very exciting stuff with Relativity Space. I wish them all the luck. We still don't have an official launch date. We're recording this on the Ides of March, 3/15. Also, Happy Pi Day, 3.14159. And I tell this every year on Pi Day. My school, Worcester Polytech, in the fight song, we say pi. That's how nerdy we were. Moving on. So, Relativity Space, we'll, if you follow us on Today in Space Pod or Today in Space Pod on Instagram, and of course Today in Space on TikTok, check us out there. We will be keeping you guys up to date on that because we're very excited to see the first 3D printed rocket light. We can light a 3D printed candle, folks. This is exciting. So we'll keep you updated on that. And let's close out with a little bit about our new telescope. All right, so our new telescope is the Vespera Observation Station from Vaonis. Vaonis is a company out of France. We actually had the chance to interview, that's how I found out about Vaonis. I had a chance to interview Cyril Dupuy, who is the CEO. We learned about his STEM origin story in the episode, how he was into optics and telescopes and astronomy, and then he had this opportunity to start this company and make observation of the stars a more regular thing, more accessible, and something that you can then just enjoy the experience of observing the stars and not be tinkering with the telescope to get it to work or setting it up every single time. And that's a major reason why I ended up getting the pre-order for the telescope. Now, the pre-order, I ended up saving some money on it. Right now, it is available on Vaonis.com. They are selling it. There's some other resellers of telescopes that have it as well. But it is right now essentially $2,500 US. So it's a lot of money. Don't get me wrong. I probably wouldn't have gotten it at that price, but it was $14.99 for pre-order, and I definitely lucked out on that. They had some delays in shipping. It did take them a while to get it to me, but they delivered me a solid product, and we're not in any way sponsored by Vaonis, although I definitely tried. But we'll see. We'll keep posting about it. We'll see what happens. But right now, this is just a customer, myself. And the reason that we bought, why did we buy this telescope? I have a Newtonian telescope in my basement. And if there's anyone that knows how to fix this, please let me know. Please email us at todayinspacepodcast@gmail.com. But the Newtonian telescope, the lens is out of whack, and I think it needs to be. There are 3 bolts that align the angle of it and kind of the height. So I definitely messed around with it and messed it up. So I have no idea how to fix that. But I figured if I have a telescope that is looking at the right thing and we know what it looks like, I can tune the other telescope to that. I don't think that's how it works, but that was my hope. So if you know a better way or someone who I can talk to about this, please let us know. Today is spacepodcast@gmail.com. So the telescope has been incredible. I got it in February. It arrived after it's almost a year since I had pre-ordered it. So it took a while, but it delivered. If you go to Today in Space Pod on Instagram, our Facebook page at Today in Space Podcast, and we also post some videos on TikTok, but the pictures that we're getting from this telescope are amazing. This telescope is definitely made for nebulas and galaxies and star clusters and things that are really grand that have lots of color. I can also look at the moon. The moon is in a it's the full it's not the full screen, but you can get an HD image of the moon, and it's great. I have a solar filter for it now, so I was able to look at the sun the other day. For us, this telescope is the only telescope and setup that I have the time for, that we can provide actual astronomy photos, actually like astrophotography for the podcast. And even to the point with how easy it's been to observe, again, when there's clear nights. I live in New England. It's a nightmare for stargazing, but it's allowed me to look at nebulas. I put it on my driveway. I put it on my back deck. And I'm able to see things that I didn't think were possible unless I was maybe like up north in Maine or something like that. So, or in Greece, man, in Greece on the islands, oh, there's no light pollution. It's great. And the power goes out every once in a while. So then it's really good. But this telescope has really allowed me to, it does what Cyril said the original goal was, the Vespera telescope. They also have the Stellina, which is higher grade. You're able to see more, higher quality, but Vespera is really the great mid-ground. You're basically buying a high-definition camera that's built into a telescope, and there's an app that you can use, and it's called Singularity, and you can, at some point, the great thing is that you can point it at whatever you want, and it tells you what's in your, it knows where you are, uses GPS, it figures out where you are, then it looks at the stars and calculates, which, I have I grew up with a telescope. That's probably one of the things that lit the early flames of space specifically. But this was the 90s, so the early 2000s, and a lot of it was like manually finding yourself, and it was just too much for a 10-year-old to really figure out. I was able to get it to work sometimes, but not always. It was a Celestron. But this telescope, I mean, the app connects, it tracks, and then I'm just able to say, all right, what's out there tonight? It tells me what's visible. It tells me the position in the sky. You can even schedule it and say, like, it'll tell you like where it is in the sky, and you can say, it tells you need 30 minutes for, an ideal exposure. You need 60 minutes for an ideal exposure. And you can look at what's available, and you can plot it out. You can say, all right, observe this from, 9 to 9:30, and then we're going to go look at M42 at 9:30 to 10, and then let's go to the Crab Nebula 10 to 10:30. So that's crazy, and there's some flaws, definitely. But I think as long as you go into it with a good expectation and understanding of what you're buying, I think this is a really great thing. Again, we don't yet have a link where you can buy it through it, so that like we get a kickback or something like that. I'm looking into some kind of like an affiliate link for that, but I'm definitely going to be putting together a video if you're at all interested in getting this for yourself. One of the things I'm really excited about is here in March, there is a comet. I missed that comet that just flew by. That was, once in a very long time. So long that people might not even remember that that we saw it before. But to be able to look at a comet and get a decent picture is crazy. I mean, that means we can keep up with astronomical events and have our own eyes on the sky. Our little spaceship today in space has gained a very valuable eye in the sky with Vespera. So we're really excited. I can't wait to we're going to put the review video out on YouTube. We're kind of switching it up. We're making sure that the audio stuff comes out, and then People of Science interviews, we're putting up the video obviously because we're doing it on Zoom anyways. But also, like, for things like the review, we want to go a little bit higher production, spend a little bit more time editing, so that way we have something that's great. And one of our most popular videos was a clip from the interview that we did with Cyril. So there's definitely something here. I'm definitely ready to speak with all the old school telescope, manual telescope, or like custom rigged telescope folks. I am not looking to replace the classic telescope. The reason I got this is because I have so many things that I tinker with. If I told you I had 5 3D printers in my basement, I would be lying to you. It would be closer to double that. And so I have too many things to tinker with. I have this Mac that decides to have issues all the time. I got to tinker with this. I tinker with 3D printers at work. I got a lot of things that I tinker with. I don't need another thing that I tinker with. I need something that I can make content with. And I think that's ultimately the power of this telescope. So we're going to put it to the test. The Great American Eclipse is next year, and we'll probably be going to Maine to watch that. So I can't wait to bring this thing up there. That's going to be very, very exciting. But that's our episode for this week, folks. Thank you for joining us. Really appreciate it. If you want to help support us, there's many ways you can do that. Obviously, our sponsors, we've got Manscaped, where you can use our code SPACE, get 20% off the store for anything in there, and free shipping. We've been using the Beard Pro Kit, and it's been great. The Beard Hedger Pro. We've also got, there's so many things like just growing a beard itself. I've started using like the beard oil. Man, that has really changed the beard game. Just that thick Greek hair, especially in the winter, it was just getting dry, and the oil has been great. So there's a lot of things like that I got to pick up some more of. But if you're looking for something, if you're a guy or you're looking for to buy for someone who's got lots of hair and you want the right tools for the job, Manscaped is there with all the stuff that you need, all the tools that you need. And if you're not a beard person, look, there's the Lawnmower 4.0 for hair in other places where you might need to groom. So check it out, manscaped.com, code word SPACE, 20% off, and free shipping. And then there's our 3D printing lab, AG 3D Printing, where we can help bring your ideas into reality. We just 3D printed a pair of Ahsoka lightsabers and a custom Ahsoka lightsaber stand for a friend. It was a really cool project, and I cannot wait to share pictures of it later. But and especially the building process, we'll do a video about it. You can check that out at AG 3D Printing on Instagram. ag3d-printing.com is our website where you can check out all the things that we're doing. We're going to be adding some more blog posts here in the future about some of our projects. And we also are there if you need a free quote on your next project, whether you know what 3D printing is and you just need someone who has one. We also design. We do CAD design. I've been designing in CAD for 15 years. So I've gotten pretty good at it. 3D printers have definitely skyrocketed that skill for me. So we're able to get designs down real fast, help you out with making something. Maybe you tried a 3D printing shop and it was a disaster and you're looking for someone who knows what they're doing. We will tell you if we can't do it. But we'll point you in the right direction. We are here to bring ideas into reality. And this is what helps keeps the light on here in the podcast and the 3D printers moving, pushing that plastic or curing that resin. So check us out. There's a lot that we're going to be doing in the future, but that's one way to support us. You can, right now, if you just want to get like a cool gift and support our 3D printing shop and the podcast, there's our Etsy shop, eg3dprinting.etsy.com. That's where you can check out all of our designs, and they get printed on demand. We don't print it. It doesn't go into the printer, or we don't have like a stock built. This is built for you. You order it, we print it. And so it's truly is a one of a kind type of thing. We've got tons of stuff, especially space related stuff. Our James Webb Space Telescope coaster. We're going to be selling a JWST model soon, so check that out, and a whole bunch of other stuff coming up. So that's another way you can support us. And then obviously you can just subscribe to the podcast. That's the easiest way. That's the free way. And it goes a long way for us. If you can rate us on Apple Podcast, give us a follow on Spotify, subscribe and like on YouTube, and just tell people about us. Share it with your other fellow space nerds, or people who are like just on the edge, like they would like to learn more. They just want to get involved a little bit more. That's what we're here to help with. So this has been Today in Space. I am Alex Girofanos. Thank you for joining us, and have a good one. Spread love and spread science. See you next time.